I am Anil Kumar. Welcome to my series on circle theorem. To begin with, we'll take up a very interesting question, which is based on chord segments relation in a circle. The question is, two chords AB and CD intersect at P such that AP equals to 4 centimeters, AB equals to 6 centimeters, and DP equals to 8 centimeters. Find the value of x. It is a multiple choice question with 4 options. The diagram is provided to you. We have this chord A to B, where AP is given to us as 4 centimeters and PB is given to us at 6 centimeters. DP is 8. CP is x plus 1. We need to find the value of x. You can pause the video, answer this question, and then look into my suggestions. The idea here is to understand the concepts. So we will answer this question later, but first let us understand the concepts. So let me begin with the theorem itself. What is, after all, the theorem when we have chords intersecting within a circle? So, chord segment theorem. When two chords intersect in a circle, the product of segments of one chord equals the product of segment of the other chord. Segments are from common point P. So as you can see here, we have two chords. One chord is from A to B. The other one is from C to D, and they intersect at the point P. Correct? So the segments AP times PB is equal to CP times PD. That is the theorem, right? So the theorem is written, which is RS times TU, right? So R times S equals to T times U. That is the theorem. Very simple proof, and that is using similar triangles. So what we do here is that we connect the points AD, as you can see, and CB. That forms two similar triangles, right? They form two similar triangles, and now these two triangles are similar. Why are they similar? Well, we know that this vertically opposite angle is same, right? That is one part. And second, we also notice that these chords actually have these angles at A and C, which include a common arc, D to B. And therefore, angle A is equal to angle C. You get the idea. So these two angles are equal. So from the property AA, the triangles are similar, right? So the reason is that triangle APD is similar to triangle CPB since angle P is common, right? So this angle P is same. A equals to angle C subtends same arc B to D. Is that clear to you? So they are similar triangles. Since they are similar triangle, the ratio of corresponding sides is equal. When you cross multiply, you get the relation. You get the idea. So basically, two chords intersect in a circle. The point P is their intersecting point. From point P, the two distances product R and U in this case and T and S in that case are equal. So that helps to answer such questions. Now we have three variations for this. One variation is that we could actually have these chords which do not intersect internally, but they have an external point where they intersect, as shown here. So when two secants are drawn from an external point, the product of one secant segment and its external segment equals to the product of other set of secant segments, right, as shown here. So now in this case, it is very similar, as you can see. Perfect. So in this case, the product of from P, the point of intersection, S times R, which is the whole length from P to P, is equal to P times C times P to D. You get the idea. So we have this relation, which is similar to what we had in the last case. Now, another case could be that we could have one secant and one tangent, right? So that is the third case. We have a tangent and a secant combination. Now think like these being same, right? So R and S are same as compared to the first equation. So R square, this means, will be equal to product of T and U. You get the idea. So we have three different cases and the concept is similar. That is, from point of intersection to the ends, we could relate using this relation RS equals to TU. You get the idea. Now, let us try the multiple choice question. How are you going to solve it? Well, I hope you got the solution. And for you to practice, I have here more questions, right? So we have these questions for you to practice. You can actually have a look at it. Try to solve them. So here's the second question for you. Practice question number 3 for you. Practice question number 4. Question 5, 6, 7, 8. And we are going to end this with a challenge question, which is right there on the screen. So you can actually figure out how do we solve this question based on the concepts learned. So this is kind of extended portion of what we are going to learn, right? So let's actually solve a simpler question before getting into the solution of our first question, right? So in this question number 1, what do we have? We have from point P, let us say this is my point P. I have, let's say this is A, this is B, this is C, and that is D. Okay. So in that case, we know 21 from P, the whole length, 21 plus 9 times 9 is equals to X plus 10 times 10 to get the answer. You get the idea. So that is how we could find the value of X. But let's first answer the very first question because of which we started this video. Now here, knowing the rule, from P, we can say that PA times PB should be equal to PC times PD. That's the theorem, right? So that means 4 times 6 is equal to X plus 1 times 8. 4 times 6 over 8, we can divide or we can just multiply these, right? So we have 24 divided by 8 is equal to X plus 1. Now 24 is 3. So 3 is equal to X plus 1. And definitely 3 minus 1 is X, which gives us the result as 2. And so option B is the correct option. So very easily we could actually solve this particular question. Now the practice questions involve the other scenarios. That is the beauty. So here we have an external point where the extended chords intersect, right? So in that case, how will you find the value of X? Let's try to figure this out. Now, total length you have to consider from A to P, which is 21 plus 9, which is equal to 30 in this case. And here it is X plus 10, correct? So therefore, we can now say that 30 times 9 should be equal to X plus 10 times 10. Solving this, we are going to get our answer, right? So let's divide by 10. So we get 30 times 9 divided by 10 equals to X plus 10, which is 3 times 9, 27 equals to x plus 10, or we have 27 minus 10 is equal to x, and that is 17. Correct? So we simplified it and got our answer. So the value of x is 17. That is how you're going to solve it. Let's take few more examples. In case you want to practice with me, you can continue with this particular video. Otherwise, you can stop it. Now here, we are considering a case where we have what? We this time have a secant and a tangent. Do you see that? So in this case, what is going to be the scenario? Since this is a tangent, consider it like same length two lines. So it is like 40 times 40, correct? Should be equal to 32 times 32 plus x. And now you can simplify this, divide by 32. So we can write, let's write 40 times 40, divide by 32 equals to 32 plus x. We can simplify this, dividing both by 8, 8 times 5, 8 times 4, and that goes 10 times. So it's easy, right? So we get 50 equals to 32 plus x, or we can find the value of x as 50 minus 32, correct? That gives you the value of x, and that is 14. So we get the value of x as 14 in this particular case. You will also notice that it is better to simplify the way we did here rather than multiply and then divide. We are working with smaller numbers in this particular case. Now here is another example to work it out. That is the point of intersection, and therefore we can now write down that 15x is equal to what? 10 times 9, right? So 10 times 9. Putting a dot in between is as good as multiplying. That is the nomenclature. So x is equal to 10 times 9 divided by 15. Does it make sense? Correct. We can now simplify. Dividing these by 5, we get 2 and 3, and that goes 3 times. And so clearly, we get the value of x as equal to 6. So that is how you can actually solve them one by one. Now in this particular case, question 4. If you pause the video, you can answer this question and then check with my solution. So in that case, we have 7 times 7 plus 11, which is 18, and that should be equal to 6 times 15x, right? So 6 times 15x. We have to isolate x, so we can write 7 times 18 over 6 equals to 15x, right? So, 15x, 15 plus 6. So let me redo this. Let's redo this. Correct. So we have, because we have to take the total length, right? 7 and 7 plus 11 is 18. So that is what you should take, right? So 7 times 18 is equal to 6 times 15x plus 6, correct? So that is what you'll do. So 7 times 18 divided by 6 is equal to 15x plus 6. And this can be simplified. 6 goes 3 times. So 21 is equal to 15x plus 6. 21 minus 6 is equal to 15x. And 21 minus 6 is what? So if you take away from 20, then it is 14. But this is 15 equals to 15x. And therefore, x is equal to 1. 15 divided by 15, correct? So that is how we can actually solve this particular question. You can continue with this list and solve most of the questions. Now, I will only give you the equation. You can do the rest on your own. So, we have 8 times 2x plus 8 equals to 7 times 3x plus 7. Solve this equation to get the value of x. Perfect. Next question. Now here we have x minus 3 times 8 should be equal to 10 times x minus 4. Next question. Here will be it is an external point. So we have 9 plus 7x times 9, okay, is equal to, here we have 10 times 10 plus 5x plus 2, correct? You can solve this equation. And that gives you, oh well, this question we have already solved. We come to the last question, which is a thinking and application question. So I'll put this as a challenge question. You can try to solve this question. In case you need help, you can always contact me on the email address given. I hope you find this interesting and useful. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.